want to go ahead and show you some examples of integrations that need to be rewritten first before finding its antiderivative. On this problem, we can see that we have 2 over the square root of x, and 2 over the square root of x can be rewritten as 2 times x to the negative 1/2. We can bring the variable to the numerator and turn the power into a negative 1/2 with respect to x. All right, that 2 is a constant, so we can hold the 2 outside and we can just take the integral of x to the negative 1/2 with respect to x. All right, we hold the constant outside and then we undo the power rule on the x to the negative 1/2, so it's x to the negative 1/2 plus 1 over negative 1/2 plus 1 plus my constant of integration. All right, and technically this 2 is getting distributed to everything inside here. All right, so we end up with 4 times x to the 1/2 plus 2c. All right, but 2c is nothing but just a constant. It's just a normal c. All right, so this is your final answer, 4 times the square root of x plus c. You can verify that the derivative of this gives me my integral right here. All right, so this is this example. All right, on this one we have to go ahead and undo this binomial that is being squared. All right, we need to go ahead and expand it, so this is equal to the integral of, well, let's see, t squared plus 1 times t squared plus 1. All right, with respect to x, we go ahead and this is equal to the integral of t to the 4 plus t squared plus t squared plus 1 with respect to t. Big mistake right here. All right, remember we can integrate with respect to any variable, just like we can take the derivative with respect to any variable, we can take the integral with respect to any variable. All right, in this case we're taking the integral with respect to t. All right, we go ahead and simplify, and this is equal to the integral of t to the 4th power plus 2t squared plus 1 with respect to t. And this is nothing but just an integral of polynomial. All right, so we go ahead and take the integral of each monomial individually, and remember that c, we're gonna hold it to the very end. All right, so this is equal to t to the 4th plus 1 over 4 plus 1 plus 2 times t to the 3 over 3 plus, well, the integral of 1, all right, what gives me the derivative of, and it gives me 1, all right, and that is t only. All right, and do not forget your c. Here we go ahead and simplify. T to the 4 plus 1 is 2 to the 5th power over 5 plus 2/3 t to the 3rd power plus t plus c. All right, and you can go ahead and take the derivative of this and verify that in fact you do get this part here. All right, this is little f of x, this is capital f of x. All right, where your constant of integration. The next problem, all right, is the same thing. It's 2 fractions that need to be split here, so this is equivalent. So this is equivalent to the integral of x cubed over x squared plus 3 over x squared with respect to x in this case, and this can be broken down into the integral of x plus dx plus the integral of 3 times x to the negative 2 dx. All right, and the integral of x is x to the 1, right, plus 1 over 1 plus 1 plus 3 times x to the negative 2 plus 1 over negative 2 plus 1 plus c, and this is equal to x squared over 2 plus, well, the negative 2 plus 1 is negative 1, so actually we have negative 3. All right, so minus 3 x to the negative 1 plus c. Well, this needs to come down. All right, so x squared over 2 minus 3 over x plus our constant of integration. In this problem, we want to be able to integrate this. However, we don't know how to do integration of products. All right, so we just have to go ahead and actually carry the product before we do the integration. In this case, we need to notice that the cube root of x is equivalent to me having the integral of x to the 1/3, all right, times x minus 4 dx. x. All right, this is equivalent to the integral of x to the 1/3 times x is x to the 1/3 plus the power 3/3. All right, so it's x to the 4/3. All right, minus 4x to the 1/3 dx. At this point, we can go ahead and undo the power rule for integrals. This is x to the 4/3 plus 1. Well, this one is disguised as 3/3 over 4/3 plus 1. And this is disguised as 3/3. Minus the 4, you hold it as a constant and you undo the power rule on the x to the 1/3 plus 3/3. 1/3 plus 3/3 plus our constant of integration, c. And in this case, this becomes x to the 7/3 over 7/3 minus 4 times x to the 4/3 divided by 4/3 plus c. Notice that I lost my integral sign when I actually undid the power rule. All right, you need to know when to drop the integral sign for correct notation. All right, just like limits, you need to know when to put limits and when to drop the limit notation. Same thing with integrals. All right, and if we go ahead and simplify, this becomes 3/7 x to the 7/3 minus 4 times 3/4 x to the 4/3 plus c. The 4 and the 4 divide out. They do not cancel. Canceling means equal to 0. And this is 3/7 x to the 7/3 minus 3 x to the 4/3 plus my constant of integration, c. All right. Here you can go ahead and factor if you like, or do any other simplification that is required to solve the problem.